In this example, we're going to um, do problems that involve um, some operations on set. And this is problem 4.2. In problem 4.2, we have three sets. And set A contains the number 1, 3, 5, 7, 8, 9. And set B I'll have 2, 4, 7, and 9. And set C have 1, 2, 3, 4, and 7. And to make things a bit more interesting, we're going to introduce the sample space S, which contain all the numbers in A, B, and C. So I will write down all the number from 1 to 9. So now let's start working on the first part A. Say you need to find the set which is the intersection of A and C. And to do that, you can start by writing down all the elements in A. So those are 1, 3, 5, 7, 8, and 9. And then you can start writing down the element in C. Now, if you run into something that is already in A, you can skip that. Right? For example, 1 is on in there, so I'm not going to write it down. Same go 3, but then we have a 2, right? So the 2 will be in this set. And then you can write 3 already there. So 4 is not in there, and 7 is not in there. So that's the end of it. So that's the set of A union C. Now in part B, we need to find the intersections of A and B. So the intersections are the elements that appear in both A and B, right? So we have 1 is in A but not in B, so it's not in there. Same with 3 and 5. But then we see 7, right? 7 is in both sets. And we got 8 is no, but 9 is good. 9 is in both A and B. So it should be in the intersection. Moving on, let's try something more complicated. Let's look at part D, where you want to find the intersection of A and B and then intersect C, right? So this is a bit more complicated than the previous ones. And to do that, um, you just do them in order, right? So I will take A union B first, right? So I will write down the set A union B. And similar to A, I'm going to write down everything in A. So that's 1, 3, 5, 7, 8, and 9. Right, and then I was the elements in B, so that's give me 2, 4. So that's A union B. Once that's done, we'll do A union B union C, right? So that's everything in A union B, right? 1, 2, 3, 4, 5, 7, 8, 9, and so looks like there's nothing else in C, right? So that's it. Now we can move on to G. Looks interesting. We got um, B intersection C union with A intersect B. Um, so right off the bat, you see that A intersect B already have, right? That's 7 and 9. Right? So we just need to find B intersect C. Right? So the elements that are in both B and C would be 2, 4, and 7. Looks like. So we got three elements. Now we can write down the intersections of B and C union with the intersections of A and B. Right? Um, so simply write down all the elements in B intersect C first, right? So that's 2, 4, 7. And then we see that 7 is already there, so 9. Um, that would be the last element. Okay. Um, to end this example, we're gonna do something a bit uh, different. That is to look at the complement, right? So the complement of set A, let's go to A prime, right? That would be all the element that is not in A, but it should be in the sample space, right? So you see that A is 1, 3, 5, 7, 8, 9, but S would be all the number from 1 to 9, right? So 1, 3, 5, 7, 8, 9 are in there, but in S we have 2, 4, and 6, the three numbers that I circled there. So that would be a complement.